Okay, so for this one, you're given the problem A aqueous plus 2B aqueous, the double arrows, 3C aqueous plus 2D aqueous. And then it says in one experiment, the initial concentration of A is 0.0321 moles, and B, the initial concentration of B is 0.0357. At equilibrium, the concentration of C is 0.0410. Calculate K. So to calculate K, you actually need all of them to be at equilibrium, and you have 2 of them at initial, and one of them you don't even have any information for. So when you have something like this and you need the equilibrium, you know you have to set up a Rice table. So for the Rice table, reactants, or some people call it the ice table, so whatever works, but I like to write my reactants. So then you put A aqueous plus 2B aqueous, the double arrows, 3C aqueous plus 2D aqueous. And I just kind of like to put in some lines so we know the separations. So for A, we get that the initial is 0.0321. The initial for B is 0.0357. We don't know these initials, but what else it gives is that at equilibrium, C is 0.0410. Okay, so this is all we're given. The change we have to calculate, and then this is our goal. If you think logically, the products, there are no products initially, right? Because you're trying to create them. So you could just fill in that these are 0.000, because that's how many zeros there are here. So these are 0 because these have to react to form these, so these are at 0. So now we can start rolling here, because we have the equilibrium, we have the initial, we need the change now, right? So if you just think about it, the change here is 0.0410, and it's positive because these are the products, right? Here's where the problem is, and where a lot of people are going to mess up. There's a stoichiometric coefficient here. So this is the change according to the coefficient. So you have to divide 0.0, my calculator's not even on. You have to do 0.041 divided by 3, and then you can get it for something else. For example, if you wanted to get it for D, the coefficient is 2. So you have to divide this by 3 and multiply by 2 to get this change. So here I divided it by 3, and then you multiply it by 2, and you get 0.0273. We'll leave it at that. So that means that at equilibrium, D is at 0.0273. Again, since this has the same coefficient as D, it's 2, we can put 0.0273, but this one's negative because it's a reactant, and reactants are diminishing in value since they're creating the product, so it's negative 0.0273. And to get A, there is no coefficient, so we could just do 0.041 divided by 3 to just get it by itself, and it's going to be negative 0.0137, and it's negative again because it's a reactant. So then here we can pretty easily calculate the change. I mean, this is the change. So you just do 0.0321 minus, you just do answer, you get 0.0184. And then you just calculate the equilibrium using the change here. Same way, so 0.0357 minus 0.0273, and you get 0.0084. So now you have all of the equilibrium numbers, and you could just use your formula. And your formula, remember, you have to use the coefficients as well. So K is equal to, the products are always on top, so first derive your formula. So it's going to be C to the third power, D to the second, over just A, because it has no coefficient, and then B to the second. From here, just plug your numbers in. So for C, you have 0.041 to the third power, 0.0273 to the second. I'm just grabbing these numbers from the table and putting them in to the formula we just derived. A is just the number we got because it has no coefficient. And then B is squared. So if you put this whole thing into your calculator, let's do it right here. Sorry, I'm going to move this away for a second so you guys can see what I'm doing. So it's, let's do this, 0.041 to the power of 3 times 0.0273 to the second power. So this whole thing, oh, sorry, I forgot some parentheses at the top. My whole thing is there can never be enough parentheses. Divided by negative 0.0184 times 0.0084 squared. Don't forget to close all of your parentheses, and then you get your answer. So K is 0.0396. You could change that up and have 1, 2, so it'd be 3.96 times 10 to the negative second. And there is your constant.